Hi everyone, good day. So today I'm going to be talking about how you can perform chi-square analysis in Excel. So first of all, we need to know what chi-square analysis is. So chi-square analysis is a type of statistical analysis that allows you to check the relationship between two categorical variables. So just like correlation, which allows you to check the relationship between two numeric variables, which I'll give the link. I explained correlation analysis in one of my videos. Chi-square analysis allows you to check the relationship between two independent variables or categorical variables. So if we have two categorical variables, I want to see how these categorical variables are related to each other, use a chi-square analysis. So when performing a chi-square analysis, first of all, you have to declare your null hypothesis and your alternative hypothesis. So the null hypothesis is going to be that there's no relationship between those two variables, while the alternative hypothesis will be that there's a relationship between those two variables. So this is a typical example I'm giving here. You can see I'm having two categorical variables here. I'm having sex and I'm also having marital status. So now this is just the count that you're having. So under each particular value of a variable, like under sex, now we have two values, male and female. Under marital status, we have single, married, and divorced. So this is the count for that of single male, and this is which is 23. This is the count for single female, which is 14. This is the count for married male, which is 31. This is the count for married female, which is 4. This is the count for divorced male, which is 54, and we have this is divorced female, which is also 23. So now here I'm looking at the values here. These are the row totals. You can see it, the sum of this of the rows of row 1, you have 37 here. The sum of row 2, which is married, we have 35, and the sum of row 3, which is 77. So I can indicate here as the row total. You can see this is going to be the row total. Then here we also have the column total. So this is going to be the column total. You can see it. So this is actually column total. So I can make this bold. Make this also bold. So you can see the column total and also have the row total. So now we also have the you can see that our values are also, say these are the count values of each particular values of the variables. So now when performing a chi-square analysis, we have what we call observed values and we have what we call expected values. So expected values are usually the row total of a particular, that is row total of a particular value here. For example, now under single male, so we're going to multiply the row total and the column total and divide it by the grand total. So we usually call this the grand total. This particular value here is called the grand total. So this particular 149 is the sum of all the row total and also the column total. You get the same value. It's 149. So this is the grand total. So we just divide. This is the formula for expected values. So I'm going to create a column of expected values, which is what you just see the row total of a particular cell multiply by what column total. Then after you multiply it, then you now divide it by the grand total. So you divide it by grand total. So you divide it by the grand total. So this is the formula for getting expected values. So we actually need this when we want to use the chi-square formula. So now I'm going to be creating another table for expected values. So now I'm going to be copying this particular table here to create my table of expected values. I'll copy this here and paste it at this place. So I'm already pasting it. This is going to be my expected values. I'm going to be making these expected values. So this is my expected values. Now I'm going to be removing these particular values here. I don't need this particular column. I'll just delete this and delete this. So I can just delete this and also delete all these values here. I don't need it. Okay, now so I want to create my expected values now. And I say expected values actually row total times column total divided by grand total. So I'm going to be selecting first of all my row total, which is this. I'm going to put equals to, select my row total, then multiply it with my column total. You can see it. So I'm going to put them in a bracket. Then I will divide it by my grand total. So I'm going to be dividing my grand total. And this will give us the expected value for single male. You can see this is now the expected value for single male. Now the next thing to also apply to this single female, male, married female, divorced male, and also divorced female. So now instead of just writing formula again, let me just make the formula absolute, sum of the sets absolute. So this is, can you see that this is our row? So I'm going to be taking each particular row for that of female. So I'm going to make in this place, I'm going to make F absolute. Then for that of the column, which is D, can you see it? I'm going to make the that is our row 8. Row 8, I'm going to make it absolute. Then I'm also going to make F8 to be absolute. That is the grand total. Then enter. So you can see what we have now. So if I'm to drag it down now for the remaining values, so you can see what I have now. So you can see for marriage now, and you can also see for divorced. So I've already made it absolute, so that's why. Now we also go for that of the females. I'm going to be dragging this. Then to also make it, since it's already absolute, I'm not going to be having any issues. So you can also see the row total for that of females. You can see for that of single female. You can see for that of married females also. You can see that of divorced female also. So I've already made it absolute, and we've already gotten the expected values for all of our cells, which is single male up to divorced female. Now we're going to use the chi-square formula to now get our p-value. So the p-value allows us to now make a decision on the null hypothesis. So let me just write my null hypothesis here. I'll write my null hypothesis here. Null hypothesis in this place will now be that there is no relationship between sex and marital status. So that is for this. Then alternative hypothesis will now be there is a relationship between sex and marital status. So now this is our null and alternative hypothesis. P-value now is what we want to get. Our p-value is what we want to get. Why we have our level of significance, which is alpha. So you can see our alpha is now, we're going to be using 0.05. So 5% level of significance, 0.05. So any value we get in our p-value, if this particular value we get in our p-value is lesser than 0.05, then we are going to be reject the null hypothesis and accept the alternative hypothesis. But if the value we get in this place is greater than 0.05, then it means our null hypothesis is true. Then we now we will fail to reject the null hypothesis, and that means our alternative hypothesis is wrong. So now for us to now get the p-value, we now use the chi-square formula. We use the chi-square dot test. Chi-square dot test. Then we now give our actual range, which is the observed values. You can see it, which is just this particular part. I'm selecting this particular range. They will now select the expected values. You can see it, then bracket, then enter. So you can now see what we now have. We have approximately 0.035. And this value now you are seeing it is lesser than this alpha value, which means our null hypothesis is wrong, and we're going to be rejecting our null hypothesis. So this means that there is a relationship between marital status and sex. So which means that marital status and sex are dependent on each other. So that is all just about the chi-square analysis. A summary and a recap. Just make sure you know that chi-square analysis is used when you want to find a relationship between categorical variables, why correlation is usually used in numerical variables. So it just work similarly, except that in chi-square analysis, you are performing a test of hypothesis. So you have to declare a null hypothesis and also an alternative hypothesis. And when your value of your p-value is greater than your alpha, then you fail to reject the null hypothesis. But if that p-value is now lesser than alpha, then you want to reject the null hypothesis. So thank you very much.